Let's try another example. Today, let's say we are given this vector B here is 10 Newton and it's 40 degree above the negative x-axis. So if I draw it on an xy axis, then this will be a 10 Newton a vector with magnitude 10 Newton, and the angle is 40 degree above the negative x-axis. Negative x-axis above. So this angle theta here is 40 degree. So now again, we want to resolve this vector. What do? We split it into its components. We split it into components. So dotted lines perpendicular to the y-axis, dotted lines perpendicular to the x-axis. Once we draw that, we know that this is how much of this is the component of B, which is in the x direction. This is the component of B, which is in the y direction. Okay, once we have done that, we can start to do our resolve. Resolve depends on SOHCAHTOA, so we make sure we need to know where is our right angle triangle. Right angle triangle must include the vector. The vector here must be the hypotenuse. Hypotenuse is the longest side, right? So of course the B must be longer than BX and BY, because BX and BY are components. Components must be smaller, right? So the B must be hypotenuse, then you must include the angle. So if B is the longer side, then you must include the angle. Then this is where your right angle triangle should be. Okay, so once you have done that, determine which side is which side. Opposite the right angle triangle, it's the hypotenuse. Then if your theta is here, opposite theta is the opposite side. Beside theta is the adjacent side. Okay, so we have labeled each side already. We can start to move on to determine bx. Okay, bx here is right on top of the adjacent side of the triangle. So we know that what we want to find is the adjacent side. What we are given is the hypotenuse, which is 10 Newton. So which equation should we pick? The one with adjacent and hypotenuse. So this cos theta is the equation that we're going to pick. Bring it down, substitute the adjacent with bx, substitute the hypotenuse with the magnitude of vector b, which is just b without the right arrow. Okay, then rearrange the equation, bring the b to the side. Okay, look at by. By is here. But by, we know that it's having the same length as the opposite side of the triangle, right? So by here is actually just opposite. So in that case, we want to pick an equation which has opposite and hypotenuse. So that's the first equation over here. Bring it down, substitute opposite with by, substitute the hypotenuse with b, rearrange, we get by equals to b sine theta. Okay, at this point, I should point out to you that actually there's a shortcut to it. If you see, if I'm finding something which is on the opposite side, it's always sine. Okay, my opposite side is the y, right? If I'm finding something on the opposite side, it's always sine theta. So you can straight away move into these steps, then add on your positive and negative sign. Okay, if you're finding something beside the angle, this is right beside the angle, right? If you're finding something beside angle, it should be cos. Okay, finding something opposite, sine. Finding something beside, cos. That's how you determine it swiftly. Okay, then what you need to do after that is just consider the direction. In this case, bx is pointing in the negative direction, so you need to introduce a negative sign. by is pointing in the positive y direction, therefore you can just keep it that way. Now once you have done this line already, only we start to substitute, and we will get negative 10 theta sum in 40 degree, then you get the answer negative 7.7. Negative means pointing in the negative x direction. Negative 7.7. Next, for by, substitute in, you get 6.4 Newton. Because it's positive, it means by it's pointing upwards in this xy axis. Okay, so this is how we resolve. And when we want to see your answer, we want to see this part of your answer and the drawing, the bx and the by. You don't need to draw this right angle triangle. You just need to draw bx and by. Okay, that's how you resolve vectors.